Hi everyone, welcome back to another video in the Web Security Academy series. In the previous video, we covered lab number 7 in the SQL injection module. So we got some hands-on experience by exploiting a union-based SQL injection in order to query the database type and version on an Oracle database. In today's video, we'll be using a union-based SQL injection attack to query the database type and version on MySQL and Microsoft databases. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Scroll down, select the learning path, scroll down, select SQL injection, scroll down again, select examining the database, and we're going to be solving the second lab titled SQL Injection Attack Querying the Database Type and Version on MySQL and Microsoft. Alright, let's get started. This lab contains a SQL injection vulnerability in the product category filter. So that's important. Let's write it down. So SQL injection, and it's in the product category filter. You can use a union attack to retrieve the results from an injected query. To solve the lab, display the database version string. So the end goal is to display the database version. You could see over here they gave us a hint. We won't look at it just yet. Instead, we'll access the lab. Okay, let's start an analysis section. Alright, so it's the same shopping application that we've been dealing with in the past couple of labs. The vulnerable field is the category field. So if we click on accessories, it'll only show us the items that are related to that category. And that's filtered based on a parameter category that is available in the URL. Now, based on the exercise, we know that this field is vulnerable to SQL injection. So to confirm that, I'm going to add a single quote, which is a character in SQL. What this will do is it will throw a syntax error, which results in an internal server error at the application level. So this confirms that this is vulnerable to SQL injection. Now let's go back. Notice over here, whatever category you filter on, the content gets displayed on the page. And this is why we know that we can use a union-based SQL injection in order to output other content from other databases. So in this scenario, we could see that there seems to be 2 columns. Now, there could be more columns that are not outputted on the page, but there's at least 2 columns that this vulnerable query is using, because you could see over here there's a title of an item and then the description of the item. And from the looks of it, it looks like both columns except text, because you could see there's text over here and there's text over here. But again, let's do our due diligence and apply all the steps. The first one is to find number of columns that the vulnerable query is using. And we said the way to do that is to use the order by clause. Now, if I'm ordering by column 1 and column 1 does not exist, the application will throw an internal server error. However, if column 1 exists, then it'll throw a 200 response, confirming that the request was successful. So let's try that out, and we'll use Burp Suite to do that. Let's click close, next, start burp. Okay, so I'm going to put it over here and then set my browser to send requests to burp. And I'm going to click on accessories again. And you'll notice over here, the request got sent to my proxy. So I'm going to send this to repeater because I'm going to use it multiple times. Remove the intercept and go to the repeater tab. Okay, so let's try ordering by the first column. Do Control U to URL encode it. And we get an internal server error, which is very weird because I know there's at least 2 columns based on what I see in the browser. So my guess is the internal server error is getting displayed because it doesn't like one of the characters that I'm using. So let's start with the comment character, which was dash dash. There's another way to comment out the rest of the query, which is using the hash sign. So let's test that out. There's one more in case this one doesn't work. So Control U, hit enter, and we get a 200 response. So the characters that it doesn't like is the dash dash characters. All right, so next let's order by the second column. This should also exist because we saw it in the browser. All right, 200 response. Let's try 3. Hit enter, and we get an internal server error. So let's write that down. And what that means is we're trying to order by a column that does not exist. And since we did this iteratively, it means that the number of columns that the vulnerable query is using is 3 minus 1, which is equal to 2. All right, the second thing to do is figure out which columns contain text, because the items that we want to display, which is the version of the database, is of text value, and so we need to find columns that accept that value. And again, based on what we saw in the browser, both columns, so the first column over here and the second column over here, they should both accept text because we can see that they contain text. So instead of doing this iteratively, I'm just going to do a union select, put both text values in both columns. So union select AA and comment out the rest of the query and test it out. Usually we do this iteratively, but again, I can see in the browser that they both accept type text. So Control U, and I did that incorrectly. Okay, hit send, and you get a 200 response, which is good. You should be able to see your A value. So you see it over here and over here. All right, so both columns accept type text. The next thing to do is to actually output data from the page. So output the version. And the way to do that is it's dependent on the type of database that you're working with. So that's where we go to the hint and look at the cheat sheet. So if you go down, you'll see for database version, it tells you for Oracle, this is the way you do it. For Microsoft, this is the way you do it. For PostgreSQL, this is the way you do it. And for MySQL, this is the way you do it. Now, I know for sure that this is not an Oracle database because this query over here would have failed because as we saw in the last lab, Oracle requires that you have a from clause and we didn't put it over here and our query worked. So the next thing to try is the Microsoft database. So select add version. So the exercise does tell you the type of database, but we're assuming that you're in a real-life engagement where you don't know what database you're dealing with. So we'll put it in our union payload. So union select add version. And then again, we have 2 columns, so we still have to put a null value over here and comment out the rest of the query. Okay. Let's paste that over here and URL encode it using Control U. Hit send, and we get a 200 response code, which is good. Now let's see if it outputted the version. Here we go. So you could see the version is 8.0.23, which I believe is MySQL, but I could be wrong. So let's go back to the page. And it says, congratulations, you've solved the lab. All right, so we've successfully completed the exercise. Now let's try and script it. Okay, so let's save this first. and start our script. So the first thing to do is import the request library, which will allow you to do get and post requests. Next, we import the sys library and URL lib3. We'll also add this line over here so that it disables any insecure request warnings. So URL lib3 dot exceptions dot insecure request warning. Okay, and set our proxy setting. So proxies is equal to HTTP 127.0.0.1 8080 and HTTPS 127.0.0.1 8080. Okay. Next, we'll create our main method. So if name is equal to main, then we've got a try and an except clause. So it'll take in the command line argument. So the first one, which is going to be the URL. So argv1.strip. And so the way I want to run my script is I want to do script.py, and it takes in one argument, which is the URL. Okay, so I'm not doing step number 1 and step number 2 in the script because we've done it in previous labs, so I'll leave it as an exercise for you to complete. Instead, I'm going to assume that I know the number of columns and I know the columns that accept text, and all I want my script to do is output the version of the database. Okay, so assuming I don't give it the correct number of arguments, I want it to print the usage instructions. So usage is name of program and then URL. Okay, and I also wanted to print an example instruction just so that it's clear. So let's say www.example.com sys.argv0, so name of the program. Okay. We forgot to exit the program, so start exit because we ran it incorrectly. All right, so assuming I give it the correct number of arguments and it saves the URL in the parameter URL or in the variable URL, I want it to print dumping the version of the database and then I'm going to create a function in a bit that is called exploit SQLi version that takes in the URL. If that function returns false, I want it to print unable to dump the database version. Okay. And if it returns true, it'll return the version, but we'll implement that logic in the function itself. All right, so let's define the function. So exploit SQLi version. Again, it takes in the URL. Now I have to build my requests. So we'll start off by defining the path. And we'll get that from over here. So it's /filter and then the category. Let's copy that. Next, we need our SQL payload. And we'll get that from our nodes. And it was this one over here. Okay, and next we need to make the request. So I'm using the get method because that's the method that is used over here. And it would be the URL plus the path plus the SQL payload. I'm going to set verify to be equal to false because I don't want to verify certificates. And I'm going to set proxies to be equal to proxies so that the request that I'm making gets sent to burp. And this way I can debug it in case my program doesn't work. Next, I'm going to set the response in a variable called res. And now I want a way to extract the version from the database. And to do that, we need to import two more libraries. So from BS4, import beautiful soup and import the regular expressions library. And what this will do is it will allow us to parse the response and extract the version of the database. Okay, so let's say soup is equal to beautiful soup res and html.parser. Now I'm going to say the version of the database is equal to soup.find. And we're going to say text is equal to re.compile. So compile the following regular expression. And what I'm looking for is a digit dot and then two more digits. Now, just to be safe, I'm going to look for 2 digits dot 2 digits dot 2 digits. So to do that, I'm going to say any number of characters and then look for 2 digits. So either 1 or 2 digits. And then look for the dot character and then look for another 2 digits, 1 or 2 digits. And then look for the dot character and then again look for another 2 digits. And then any number of characters again. Now, it's very easy to mess up regular expressions, and so what I'm going to do is I'm going to copy this and I'm going to confirm it in the page regex 101. I'm going to put it over here and it looks like it's a proper regular expression. Now I want to see if it will actually match on the page over here. So let's just copy this portion of the page and put it here. And it says it matched it. So this should work. Theoretically, this should work because I put my regular expression over here. I put a portion of the content of the page and it was able to match on this one over here as seen in this screen response. So good. That gives me some level of assurance. Now let's go back to burp. All right. So the next thing to do is to check if the version is none. So it didn't find the version at all. Then I want it to return false. And if it returns false, it'll print the statement over here, unable to dump the database version. Otherwise, it found the version and I want it to print. The database version is, and version over here. So the version variable that we extracted over here. All right, and then return true. Okay, we saved that. Now let's click on terminal, new terminal, and run it. But before we do that, let's go to the proxy tab and history tab and click over here. This way we could see our requests in real time. So SQLi lab08.py, and we need the URL. I'm assuming it timed out. Let's double check that. And it did, so we have to generate a new instance of the lab. Okay, let's grab the URL, add it over here, and remove the slash because we already included it in the path over here, and hit enter. And we get an invalid syntax error, and it's on line 21. So it's because I forgot to add the plus sign. Save it again, clear, and let's run it one more time. Okay, that's interesting. So I'm getting an insecure warning error, although I've already removed that using this over here. Okay, so it looks like I've removed the incorrect one. So let's do it one more time. Dot insecure request warning. Here we go. Let's clear it one more time. Hit enter. And it says unable to dump the database version. Now this is where burp comes in handy. So let's look at what response it's getting, and it looks like it's getting an internal server error. Okay, and I know why. You could see over here the hash is in the string, but it's not getting displayed in the request. So I think it's intercepting it as a comment in Python, but I could be wrong. So the way to fix that is to just URL encode it from the get-go. So %23. And let's save it one more time and see if it actually views it as part of the query. Hit enter. Okay. So it says the database version is 8.0.23, so it found it. And if we look over here, you'll see that it intercepted it as part of the URL. Okay, so I'm not sure if this is a Python issue or a URL encoding issue that caused this. But if you do URL encode it, the script works. Alright, so we've successfully completed the exercise. To recap, in this video, we first manually ran a SQL injection union attack that allowed us to query the database type and version on a MySQL database. We then scripted the exploit so that it automatically does that for us. In the next lab, we'll learn how to exploit a union-based SQL injection vulnerability in order to list the database content on non-Oracle databases. If you liked the video, hit the subscribe and share button so that it reaches a wider audience. Also comment below what you learned and what you would like to see more of in the future. Thank you and see you in the next video.